toppling. Toppling is a failure which involves overturning of columns of blocks, as we saw in the picture. I have a slope, and then I have series of the blocks coming down, okay? And that is what depicts what we call a toppling. So I have toppling failure involves overturning of columns of blocks of rocks about some fixed base. So the base here is fixed, and I have the material falling over and associated with steep slopes. So you have, let's say, a formation that is very strong, and so you decided to go with an angle that is steep. Then mind you that there isn't any discontinuity at the surface you don't know about, because if there is, then you are going to have toppling failure occurring without your knowledge. Then in this case, the shape of the block as well as the width is important. So you need to know the shape of the blocks that are going to cause the toppling, and then how heavy they are. In toppling failure, the direction of the dip plane is usually towards the massive, okay? The massive is the formation that is going to cause the failure. A group of material that is going to cause the failure is what we call the, so for example, if I have a crust, okay, that is being demarcated by a series of faults, then I term that as a massive, and that is what we are talking about. So the direction of dip of plane is usually towards the massive. And then toppling failure occurs as a result of sliding and or toppling of the individual blocks. But this is also a picture that is showing us how toppling material could, toppling failure could also occur. So I have my steep wall in this particular picture, and then series of blocks falling over. You see how they are. So you need to know their weight, and then get to know the weight of it, as well as the shapes that they are, that have been formed, which will cause this type of failure. So to establish equilibrium, to ensure that your toppling failure, which is bound to occur, do not, where you, the engineer, will put in some measures to ensure equilibrium, then it is saying you should have this passes through. So consider the location of the line of action of the force due to gravity. So you remember they said we should know the weight of the material, which can help us determine their direction as to how they are going to fall. Because when we drew this diagram in our previous slides, we said that the material has a weight that was acting downwards, okay? And that was used in resolving these W sine phi and then the cos sine phi that was to occur here. W cos phi. So this two, we need to know the weight of the material that is going. So when we get to know the weight, then we'll be able to tell the location or how the failure is going to occur. And then this passes through the center of gravity. So usually if you get to know the weight of the material and the direction with which the toppling can occur, you'll be able to measure the center of gravity. You can assume the center of gravity that if the material is this heavy and it is tilted at a certain angle, then its weight is likely to be acting in this direction. Then you can help you resolve your forces and then avoid this type of toppling failure to occur. Then it says that of block N will coincide with the lower apex of the block if B over H is equal to tan phi. So the B here is assuming the failure is to occur. You know the distance of the block at the top, which is the length, and then the height of the block. So if I measure and this ratio is greater than the value I'm going to get if I measure the phi, and the phi is the angle at which the failure is to occur. If I get to know that angle, okay, and I measure and I realize this man here is greater than it, then there's going to be that failure. If this is less, but if this is more, there wouldn't be failure. So the resulting 4 categories of equilibrium, what are the equilibrium you need to consider? And these are this. If you get to know these equilibrium and you satisfy all of them, then you are able to have what we call a stable condition, and then this type of failure can be avoided. So for turbulent failure to take place, the discontinuities causing the failure must be inclined parallel or almost parallel to the cut face. So you have your cut face. So you have to make sure that you have your discontinuities acting parallel to the cut face. And if you have that, toppling failure cannot occur because you have it standing like this. So assuming you designed and your this thing was steep, because we said that for this to occur, you need to have a steep face for toppling failure to occur. And so if you have a steep face, you know your materials are already at a certain angle parallel to the face. So once you have a steep face, it will allow this material to be broken and then they can topple over one after the other. So they are saying that for us to have a stable condition for toppling failure, we must always ensure that the angle that we are going to use for our cut face is always parallel to the material. Then circular failures may occur in rock masses which are so intensely fractured in relation to the scale of the slope that they may be considered as random or jointed or an isotropic. So in highly weathered material, non-circular failures may occur along a combination of existing joints and failure through weak points, previously intact material. So the major issue with this type of failure is when you have weathering. So it means for you to avoid toppling failure, then you need to have a fair idea of a circular failure. You need to have a fair idea of the durability of the formation you are dealing with. And this can be tested using your slick durability test. So if you get to know this feature, then it will help you to know whether, so if your slick durability values are quite low, then you have to be mindful that you are likely to have this type of failure going forward. And so you should check out for that. So circular failure in most cases happen in soft material. So once the material is soft, it means that you have lower values for durability. So you have in soft material such as overburden. So that is why you see it in the diagram we saw. You saw it sweeping as if it was a landslide, sweeping off from the surface. And so overburden or waste dams, where materials are very weak. So if you have these situations, you should always expect that. And that is why we said that if you are designing a waste dump, you have to know the angle of repose of the slope or the material, and then it can help you define what angle will make it to be stable. If not, you pile your material and one day you get up and come and see that the whole of the top at a certain distance has been swept off, as if someone used a dozer to push it from the top to a certain section, and that is circular failure. So this type of failure can also happen in very jointed. Very jointed means that the various rock in the intact phase or the rock mass has been broken so badly that they behave as though it was a waste material. And so this type of failure can also happen, or highly altered or weathered material. So this type of failure has been treated in soil mechanics for a long time. In circular failure, there is no defined structural pattern, and the failure surface is free to find a line of least resistance through the slope. So the failure geometry is circular. So the conditions under which circular failure will occur arise when the individual particles in the soil or rock mass are very small compared with the size of the slope. When the individual particles that are forming the formation itself are too small compared to the size of the slope. So hence, the broken material or the broken rock in a field will tend to behave as a soil and fill in a circular mode when the slope dimensions are substantially greater than the dimensions of the rock fragments. Similarly, in soil consisting of sand, silt, and smaller particles. So it means that this type of failure usually will happen when you have soils, okay? And so it simply means in the rock where we work as mining engineers, it can happen in the dump or where you have heaps of overburden material, okay? Or you have a poorly or a disjointed or joints, several joints within your rock mass, then you should expect circular failure to occur. So highly altered and weathered rocks, as well as rocks with closely spaced, randomly oriented discontinuities, such as some rapidly cooled basalt, will also tend to fail in this manner. So what should we do to avoid some of these? So the orientation of the cut face must not be chosen at random, but should be carefully selected to ensure maximum stability. So you have, and they have stated that if we want to be on the safer side during the exploration and prospecting stages, we should come up with the various features and discontinuities that are likely to occur when we pick out our drill core, to give us the information that these are how our materials are going to be oriented, our discontinuities are oriented, and that will help us to choose the best cut face or cut face direction to avoid this failure. An incorrect choice of orientation of the cut face can lead to development of deformation in the rock. The cut face orientation needs to be determined at early stage of the mine design, and the orientation can be determined by primarily preliminary evaluation of what? The geology data or geological data from prospecting and exploration. And when discontinuities are known, cut face should be oriented to avoid possible failures. So to improve the safety of slope, 3 measures must be taken. Change the cut face direction, reduce the angle of the dip of the face, and then change the cut face direction and reduce. So you either do this or do that, or do the 2. Do 1 and 2, and these will resolve these issues we are having. So our next topic will be design of underground excavation pillars. Design of underground excavation pillars. What are some of the analysis that go into design of excavation pillars? Okay, and God willing, when we meet tomorrow, we shall have a look at that. And so, in the absence of any concerns or questions, I earlier on asked the question when we had about 13 people, how the assignment was going, but the class was silent, which means it's either we have not started or we have finished. So we don't have issues. Hope we are on it. We are on it. Okay, that's nice.
Yes, we are on it, Doc. We are hoping to submit before time.
All right. That will be fine. Okay, so thank you so much for coming, and I hope to meet you, God willing, tomorrow, where we look at the design of pillars, design of underground excavation and pillars. And gradually we are getting to the end of our material. Then we'll call it, we'll meet another time, maybe during my management. That one, my senior will be handling that, Prophet J. Okay, so have a great morning and see you tomorrow.